Dari, hello. It's midway through 2021 and we are testing Disk D13, which is a Seagate ST238R. We're going to use the Kremenko harness system to test it, and indeed that's where it's been used, and I'll cover the history whilst we're booting. So I'll just get the Kremenko system started. So I've got a serial terminal window open. Just powered on the Kremenko system. Hit enter a few times. So we've got the IDOS monitor started. I can do a low-level test of this disk. Again, it's Disk D13. It's a 20 megabyte disk. We're going to select high, H for hard, unit 0. And as you can see, the seek tests were fine and the data read test was fine. We're just going to finish off doing the write test. That's also fine. So the next thing is we're going to boot the operating system Chromix 168, which is one of the last releases of Chromix. Dates to about, I'd say about 1984. So it's well over 30 years old. Now, this Unix-like operating system can be booted from a floppy disk, rather like early Linux. So that's what we're going to do. We're going to use the STDC hard disk controller, which you saw above. This was actually the monitor we were talking to, but the monitor knows how to speak to the STDC hard disk controller. So this was the 64 FDC floppy disk controller talking via its ROM monitor to the STDC disk controller. Right, now I've got time for waffling later. Let's get a move on. Right, so booting the floppy. Going to switch off screen pause, and we're going to run disk info to have a look at the disk. So as shown above, we've got a disk that's partitioned for Chromix. These are the partitions. The total free space is 24320 kilobytes, starting at cylinder 1 and in this case ending at cylinder 608. Yes, so we have a few cylinders that are not being used, and that's because we've declared 28 alternate tracks. Now, of course, these things only have relevance to Kremenko users, and the point of this video is to test the disk. And whilst it's doing this, I shall be chattering on about Kremenko systems as usual. So we're going to do a read all command. So we're going to do a read all of /dev/std31. Whilst that command is running, so this is the read all command will read every surface of every track on this hard drive, and it knows to read surfaces 0 to 3 and cylinders 0 to 614 because it's looked at the header of the disk on track 0, and when we initialize the disk we have told the system that this is the geometry of the disk. So if we would have liked, we could have said it had 3 heads and 600 tracks, and then that would be 3 and 600 here, and so the system wouldn't use the other parts of the disk. That's quite flexible because if, for example, I don't know, suppose surface out of 0, 1, 2, 3, suppose surface 3 was completely dead, for whatever reason, wholly dead, we could just say it had a different number of heads. But the conventional way to map out bad sectors is using the alternate track table. And you can see we've got 28 alternate tracks defined, and dividing by 4 we've got 7 tracks. So sorry, 7 cylinders. So 7 cylinders, each cylinder's got 4 heads, therefore 7 times 4 is 28. We've got the capability to remap 28 tracks. Now Karenko uses track formatting. You can't just substitute one sector of one track. You have to map it. So if any part of a track is defective, and you can see there are 20 sectors per track, you have to map away the entire track, which is a little bit wasteful, but the reason that that's done is that the STDC disk controller reads tracks, a whole track at a time, and that's quite a bit faster than reading individual sectors. So this was all done in the 1980s for speed, but you might be amused to hear that the speed we're talking about in those days, which was quite quick, was certainly less than 100 kilobytes per second. It was less than 100 kilobytes per second transfer. Okay, we're up to track 500, and I have no errors so far whatsoever. So when you had bought a Seagate drive, you would look at the top of the drive, and on the top of the drive would be a defect list. So it would be almost impossible to buy a drive without any defects. Defects were to be expected, and it was up to the operating system vendor to remap those defects. I'm very pleased to say right now, wow, absolutely 100% clean. So on the actual top of the disk is a single defect, but we're reading this disk right now and it looks 100% clean, which is astonishing given that this is a almost 40-year-old hard drive, spinning at 3600 RPM, and as you see 615 cylinders using 4 heads per cylinder. Okay, I think we're almost done here. The drive's going to be for sale presently, and thanks for watching. I think to be a paranoid Android, is it possible that I can power the system down, reset the computer, and seek to track 0? It was a bit of voodoo in the days as to trying to get the if I type in ST00 here, it didn't work, did it? Let's do a T for test. Let's do an H. So, selecting unit 0, that was the default. I hit enter too soon really. Should have put in a 0. You can hear all the seeking, so it's seeking, I believe, right to the beginning. And we'll just escape here. ST, so now we're actually talking to the disk itself. If I do seek 20, yeah, seek 0. Let's do seek 500, 550. Do you know what? I think that's hex. Let's do seek 200. Yeah, seek 0. Okay, we're going to leave the system at track 0. And now we're going to power off. Okay, Dari, thanks for watching.